Hello. In this video, we are going to begin our linear functions unit by beginning with relations and functions. What is a relation? A relation is a set of ordered pairs. It can be shown as a table, a mapping, graph, or an equation. Now, our domain in a relation is our set of x values. Our range in a relation is a set of our y values. Functions. Each element in the domain is paired with exactly one element of a range. Relations can be functions, but not all relations are functions. So all functions are relations, but not all relations are functions. So we use this test to determine if a relation is indeed a function. So what does it mean that domain is paired with exactly one element of the range? That means that our x's are not going to repeat. So below we have a relation, 0, 1, negative 5, 2, 6, negative 2, 5, 6. The question is this a function? We have 0, negative 5, 6, and 5. None of our x's repeated, so this is a function. Let's look at another example. We have negative 7, 2, 6, negative 1, 6, 2, and negative 3, 9. Our domain is our set of x values, which are negative 7, 6, 6, and negative 3. Our question is, do any of these x values repeat? Yes, we see 2 6's. Therefore, the second example is not a function. So, let's look at what this means graphically. Here we have a line and we have a circle. We have to use the vertical line test to determine if either of these or both of these or one of these is a function. So let's begin with our line. We have a vertical line. We're going to drag it across the graph from left to right. If the pink line touches the green line in 2 places, it is not a function. So if our vertical line touches y equals x in 2 places, it is not a function. Let's see if that happens. As it drags across, we notice that it does not touch the green line twice in 2 places, or twice in 1 place at the same time. If you need to watch that again, just flip back about 15 seconds and you can watch it again. So our first line is a function, our first graph. Now let's test our second graph. Here's our vertical line. We are going to drag it across. Let's see. It is touching 2 points of our green function, or our green graph. So therefore, our circle is not a function. Our line was, our circle was not. Our line, y equals x, passed the vertical line test. Our circle did not. So it did not pass the vertical line test. Example 1, we're going to find the domain and range of the relation, and then we're going to determine if it's a function. So we know we need to find the domain and range and determine if it's a function. That's what's happening here. I'm giving you a relation negative 1, negative 9, 0, negative 5, 4, 3, and 6, negative 2. Our first job is to find the domain. Our domain is our set of x values. In this case, that is negative 1, 0, 4, and 6. Our next job is to determine the range, and that is our y values. In this example, that's negative 9, negative 5, 3, and negative 2. Our last set of instructions were to determine if this is a function or not. To determine if a relation is a function, we must examine the domain. Our domain is negative 1, 0, 4, and 6. Do any of those x values repeat? No, they do not, so this relation is a function. We're going to do the same thing again. We're going to find the domain and range, and we're going to determine if it's a function, but you're going to try it by yourself. So I've given you a relation. You're going to find the domain, range, and determine if it's a function in 20 seconds. Begin now. Okay, time's up. Your domain is your set of x values, so hopefully you determine that your domain is 5, negative 3, 5, and 8. Your range is your y value, so hopefully you determined that your range was 2, 4, -6, and 0. Lastly, you had to answer the question, is this a function? We have 2 5s, so our x's did repeat. Therefore, this is not a function. Now, we're doing the same thing again, but instead of looking at a set of ordered pairs, we are going to look at a table. I almost said mapping. At a table. Here, we need to find our domain, which is -4, 0, 2, and 7. Our range, 3, -1, 3, and -8. And we need to determine if it's a function. Well, we saw that we have 2 3s in our range, but does that matter? Absolutely not. We are only looking at our x values to determine if it's a function. Do any of our x values repeat? No. So this is a function. Doing the same thing again, you are going to try it yourself with 20 seconds. You're going to find the domain, range, and the function. Are you ready? Begin now. All right, 20 seconds. That goes by super fast. Okay, domain is our x values, 10, 15, 18, 24. Range is our y values, 0, 3, 7, 11. Is this a function? Did any of our domain values repeat? No, they did not, so yes, this is a function. Example 3, we want to find the domain and range of the relation, and we're going to determine if it's a function. This time we have a map. So, each line pairs an x with a y. So it's 4 is paired with 0, 2 is paired with 3, 5 is paired with 7, and 5 is paired with 9. So let's find our domain. 4, -4, those negatives are in the wrong spot. 4, -2, and 5. Our range, 0, 3, 7, 9. Is this a function? One thing I want you to notice is there are 3 elements in our domain and 4 elements in our range. Therefore, since there's one less element in our domain, we can automatically come to the conclusion that one of these values had to repeat. Therefore, this is not a function. We are still finding the domain and range and determining if it's a function. And guess what? You're trying it by yourself. And we're going to find the domain, range, and determine if it's a function in 20 seconds, beginning now. Okay, let's determine our domain. 2, 8, 13, and 17. Let's determine our domain. 2, 8, 13, and 17. What about our range? -4, 0, 7. Does it matter that we have 3 elements in our range and 4 elements in our domain? No. We're just happy to see that we have more elements, or at least equal number of elements in our domain than what we have in our range. So is this a function? Yes, it is a function. Now it is time to move to more difficult scenarios. Instead of looking at a simple map, table, or set of ordered pairs, we're going to look at a graph. On this graph, we have a set of ordered pairs that have been plotted. And we are going to determine our domain and range and determine if it's a function. So we have -3, 1, -3, -2, 0, 0, 2, 2, and 3, -1. We need to determine the domain. The domain is all of our x values, -3, 0, 2, and 3. Our range is our y values, -2, -1, 0, 1, and 2. Is this a function? How many elements do we have in our domain? 4. How many elements do we have in our range? 5. We have one less element in our domain than in our range, so we know that one of our domains had to double up. Guess what? If you look at the graph, now those 2 points are green. -3, 1, and -3, -2 have failed the vertical line test. So this is not a function. It is simply a relation. Let's look at another one where we once again examine the domain and range and determine if it's a function. We have a line. What is our domain? Okay, we looked at a line earlier, but we didn't talk about defining the domain. If we take our vertical line and we drag it across our entire graph, is there ever a spot where our graph cannot be? No. So let's learn about the correct way to write this. So this means that our domain is all real numbers. We're going to write it in set notation. So we have to say braces x, and there's a line that means such that. X exists, that's what that little weird E means, in all real numbers, that bolded R. Now, sometimes if you're writing this on your paper, where we have the word domain written all the way out, you could simply write a capital D. Same idea with the range. We are going to do a horizontal line, starting at the bottom and dragging it all the way up. Is there anywhere this function is not going to be? No. So our range is still all real numbers. So we have y such that y exists in all real numbers. And make sure you use braces instead of brackets. Lastly, is this a function? Yes, it is, because it passed the vertical line test. Now, we're going to look at another function. C is going to be this weird little v thing that's going on. I don't even know what to call this. You're going to determine the domain, the range, and if it's a function or not. Oh, we're doing it together, just kidding. So I have highlighted the part of our function, or the part of the graph, the coordinate plane that is included in our function. Our relation, we don't even know if it's a function yet. And our relation, the shaded part. Anything that's outside the shaded part is not necessarily in the function. So we need to determine what is the domain. We have a vertical line. We're going to drag it across. Is there anywhere that our line was not? It was not before -4. So we have x such that our function is only greater than or equal to -4. So x is greater than or equal to -4. Our range, we're going to do a horizontal line test, and we're going to drag it up the entire graph. And now we're going to say, is there anywhere that this function could not be in terms of y? No. So it's all real numbers. So we have y such that y exists in all real numbers. Is this a function? No, it's not. It failed the vertical line test. Remember when we dragged that pink line across? There in the very beginning, all the way up to probably -1 that you can see very clearly, it failed the vertical line test. And it would continue to fail the vertical line test throughout the graph the farther and farther you zoomed out. Now, I know example 4, A, B, and C were more confusing than the first part of the function. But if you need additional help, make sure you come ask, because that's what I'm here for. Okay, so this is the last part of this lesson. We are going to do one where I want you to try it by yourself. We have a function, and it is an ellipse. Looks like a circle, but not quite. It's an ellipse. So I want you to determine the domain, range, and determine if it's a function or not. You're going to have 20 seconds. Begin now. Okay, 20 seconds. I know that was super fast, but hopefully you were able to see at least some key features of what's happening with this graph. So I shaded the inside of this circle. The shading takes you from x to x and from y to y. So let's look at the domain. We are starting at -2. Anything that comes before -2, there's nothing there. So we're starting at -2. And then all the way across the graph, we're still there. And we're ending at +5. So we know that x, such that x is in between -2 and, that's supposed to say 5. Sorry guys, that is supposed to say 5. X is between -2 and 5. So -2 is less than or equal to x is less than or equal to 5, not 4. Let's look at our range. Our range, we are beginning at -2. At the bottom, we go from least to greatest. We're beginning at -2, and we are going all the way up continuously until 4. So y such that y is in between -2 and 4. Okay, that doesn't even say a y or a 4. But -2 is less than or equal to y is less than or equal to 4. Please excuse my typo errors. Now my next question for you is this a function? No, it's not a function because it failed the vertical line test an infinite number of times. So hopefully by this 4th example of actual functions on graphs or relations on graphs, you have improved your ability in determining domain and range. If you need extra help, make sure you seek out that help from me. Tune in for our next video as we continue investigating functions.